Hello everyone, welcome back to my channel. Hi Mathematics. Today we have very interesting and in the same way this is a very tricky question. X to the 6th power equal to x minus 1 to the 6th power. And a lot of students might be saying, hey mister, let's just cancel this 6th power right here and we can easily find this x real quick just in 5 seconds. And here's my answer. This is not the best way to solve this question because we have 6th power. And according to a fundamental theorem of algebra, we will have like at least 6 roots. We don't know how many real number roots, how many complex roots, but at least we have 6 roots. So this is not the best way to cancel this 6th power. So right now I'm going to show you how can you solve this question correctly and step by step. Let's do this right now. So first of all, let's bring this x minus 1 to the 6th power from our right side to left side. Okay, as a result, what do we have? X to the 6th power minus x minus 1 to the 6th power, x minus 1 to the 6th power, and of course equal to 0. This is our first step. Right now, x to the 6th power we can write as x cubed to the 2nd power. So let's do this right now. So we have x cubed, we're gonna raise this to the 2nd power according to a basic school property. When we need to raise this, we need to multiply 3 times 2, so as a result we have absolutely the same fix. So absolutely the same expression, and minus, and we're gonna do the same thing with this expression. So we're gonna write it as x minus 1 to the 3rd power, all right, and we're gonna raise these, I'm using this type of brackets, we're gonna raise these to the 2nd power. Then we multiply 3 times 2, and as a result we have absolutely the same expression, so equal to 0. Alright, so what we're going to do next, I hope you see this expression, I hope you see that this is like a difference of squares. So for example, this is our a, this is our b right here, so as a result we can consider it as a square minus b square. And I think you know this formula, we have a square minus b square, okay, a square minus b square, this is our all-known formula. We can easily write it as a plus b times a minus b, all right, a minus b. So I hope you know this formula, and right now let's factor this according to this formula difference of squares. But we don't have a and b, we have x cubed and x minus 1 to the 3rd power. So let's do this right now. So we have in first parenthesis we have x cubed, let's go with the plus sign, so plus x minus 1 to the 3rd power, so x minus 1 to the 3rd power, and we're going to multiply it by the second parenthesis but with the negative sign. So we have x cubed minus x minus 1 to the 3rd power equal to 0. Right now let's simplify this a little bit. Let's try to simplify this expression inside both parentheses, and then we can easily write equations because we have right here 0 and of course a product of parentheses equal to 0 and each of these parentheses equal to 0. So I hope everything will be okay. But first of all, let's look closely. What do we have right here? Inside first parenthesis we have x cubed plus some expression x minus 1 to the 3rd power. So this is like a sum of two cubes, yeah? So we can easily consider it as a sum of two cubes. But first of all, let's remember a formula when we can talk about sum of two cubes. So a cube plus b cube, and this is equal to, we have a plus b in first parenthesis, and of course we will have in second parenthesis we have a square minus ab and plus b square. And let's look closely what we have in the second parenthesis. In the second parenthesis we have difference of two cubes, so a completely opposite formula with this minus right here and with this plus, I guess, yeah. So we have right here a cube minus b cube, and we can easily consider this formula. We have a minus b, and inside another parenthesis we have a square plus ab and plus b square. Okay, and according to these two formulas, this one we're gonna apply right here, and this second formula we're gonna apply right here. So as a result, we can easily simplify this a little bit. So let's do this right now. So the first of all, addition formula. Let's start on the left side because I need a lot of space right here. So let's do this right now. So we have right here sum of two cubes. Let's apply this formula. So we have x plus x minus 1, this is our first parenthesis, and we're gonna multiply it by this expression with the minus sign. So when we plug in it, we have x square minus x times x minus 1, and plus x minus 1 square, we're gonna squared it. This is our first formula when we apply this addition formula according to our expression inside parentheses. Right now let's apply the second formula. Let's apply difference of two squares. Let's apply right here. So let's continue. I hope I have space right here. So the second formula, we have multiplication x minus x minus 1 minus 1, and the second parenthesis. I really hope I get enough space right here. So the second parenthesis, we're gonna write this one, all with addition sign. So we have x square plus x minus 1, x times x minus 1 right here, and plus x minus 1 square, and plus x minus 1 square. Just sorry about it, because I need to write it in one line just for better understanding. But right now we're going to simplify it, and we have like enough space right here. So just sorry about that. I hope you see this whole expression, of course, equal to 0. And right now let's look closely. When we simplify this a little bit, we have x plus x minus 1. This is equal to 2x minus 1. So let's start right here. I think I will have enough space right now. So we have 2x minus 1, 2x minus 1 in the first parenthesis. In the second parenthesis, let's multiply it. Okay, doesn't matter. Let's multiply the second parenthesis. We have x square minus, we have x square minus x square. The next we have plus x, and we have plus our formula, x square minus 2x and plus 1, plus x square minus 2x and plus 1. All right, and right now let's look closely right here. X minus x and minus 1. So we have plus 1. We can easily cancel this x minus x, and in these parentheses we have only 1, which simplifies us a lot. As you can see right now, we have enough space. And right now let's simplify this our second expression. So let's do this. So we have x square plus x square minus x and plus this formula, plus x square minus 2x and plus 1 equal to 0. All right, really great. And we finally can easily simplify this, because right now we can easily cancel this x square. As a result, we have x square minus x plus 1. So let's do this right now. So we have 2x minus 1 in the first parenthesis, 2x minus 1 in the first parenthesis. In the second parenthesis, we have x square minus x plus 1, x square minus x plus 1. And the next thing, we have 1 right here, so let's write it. It changed nothing, but let's write it. And the second thing, we have this parenthesis. Let's see what we can simplify right here. So let's do this. So we have x square plus x square plus x square. This is equal to 3x square. What are we going to do next? We have minus x minus 2x, so minus 3x, and we have plus 1, equal to 0. So as you can see, we have like a greater expression for us. This one is really long. We simplify it, and we have like a product of 4 parentheses. And right now it's really great to solve it, because we have only a product of 2 parentheses, and a product of 2 parentheses equal to 0 when the first parenthesis is equal to 0, the second or the third or the fourth. So let's start, for example, with the obvious one. Let's start right here. So 2x minus 1, let's start, for example, with these parentheses. So we have 2x minus 1 equal to 0. Right here we have 2x equal to 1, and x first equal to 1/2. And this is our first root. We're going to check it a little bit later, but right now let's solve another expression. Let's solve this another parenthesis. This one we can easily cancel this, okay? You can just cancel this, because this is like multiplication by 1. We can easily cancel this. It change nothing. So we still have 2 parentheses, the first one and the second one, and this is a great parenthesis for us, because this is a quadratic equations. This is both expressions are quadratic equations. So right now let's solve it. Let's see what will happen when we solve this, for example, quadratic equation. So we have x square minus x and plus 1 equal to 0. Let's see what will happen when we find, for example, our discriminant. Let's do this right now. So when we find our discriminant equal to b squared minus 4ac, we're gonna plug in each of these values. So we have a equal to 1, b equal to minus 1 right here, yeah, b equal to minus 1, and c equal to 1. So let's find our discriminant. So d equal to b squared, we have 1 minus 4 times 1 and times 1. 1 minus 4 equal to minus 3. And as you can see right here, we have complex roots. So right now let's find this complex root. So we have x second and third, because we have x first, and this is x second and third equal to minus b. So we have minus 1 equal to 1, plus minus square root of d, so plus minus square root of minus 3, and all over 2a, 2 times 1. This is our x second and third. We can easily simplify it in one step right here, so we can easily write it as 1 plus minus square root of minus 3. We can easily split as square root of minus 1 times square root of 3, and we divide it by 2, and as a result we have x second and third. We can easily do this. We can easily write it as 1 plus minus I square root of 3 over 2, and for better understanding, like when we have complex numbers, we can easily split it by real parts plus minus imaginary parts. Okay, so we can easily write it as x second and third equal to, we have 1/2 plus minus I square root of 3 over 2. We can easily split it by real part and by imaginary part. All right, so I hope you understand this step. Right now the second parenthesis, this one, let's solve it. Let's see what will happen when we solve these parentheses. So let's do this right now. So we have 3x squared minus 3x and plus 1 equal to 0. Let's find our discriminant real quick right here without this a, b, and c. I hope you know it. So we have discriminant equal to b squared minus 4ac. So 3 minus 3 squared equal to 9 minus 4 times 3 times 1 equal to, we have 9 minus 12 equal to, as you can see, the same minus 3. So we will have like x fourths and x fifths equal to, we have minus b3 plus minus square root of discriminant square root of minus 3, and all over we're going to divide it by 2. And as you can see, we have, looks like absolutely the same thing. Let's do this. So we have x 4 and fifths equal to, we have 3 plus minus, right here we can easily write it as I times square root of 3, so I times square root of 3, and we're going to divide it by 2. Right here we have, sorry, right here we have 3, yeah, we have 2 times 3, so as a result we can divide it by 6, so don't forget about this. So we have x fourths and fifths equal to, we have 3 over 6 equal to 1/2, yeah, 1/2 plus minus, yeah, plus minus. We have right here I square root of 3 over 6, so I square root of 3 over 6, or we can easily multiply numerator and denominator by this square root of 3. Yeah, we can easily do this. We can easily multiply it right here, and as a result in our numerator we have 3, which cancelled with this 6. So as a result we have only I in our numerator and 2 times square root of 3 in our denominator. So x 4 and fifths equal to 1/2 plus minus I over 2 square root of 3. And this is our all solutions, all roots. Right now I'm going to show you a final answer to this question, but first of all I want to mention one really important moment, because a lot of students, I have enough space right here, because a lot of students think that they can easily cancel these 6 roots. So in the beginning what we have x to the 6th power, yeah, x to the 6th power equal to x minus 1 to the 6th power. And a lot of students might be saying, okay, let's cancel this 6th root, let's cancel this 6th root, and as a result we have x equal to x minus 1, something like that. And they say, okay, right here when we subtract x from both sides, we will have like 0 on the left side and equal to minus 1. And they confused a lot because they think that this is a correct approach when we cancel 6th root on both sides. Okay, this is extremely important moment right now, because a lot of students are confused about this step. But what is the correct approach when you cancel this 6th root? Don't forget about, this looks like a first approach. This is bad approach, yeah. But second approach, if you want to find a real number roots, when you have like x to the 6th power equal to x minus 1 to the 6th power, when you want to do this, just cancel this 6th root if you want to do this. But don't forget about absolute value, yeah. Don't forget about this. So absolute value of x minus 1. So don't forget about these absolute value brackets, because with absolute value brackets we can easily consider it as x equal to minus x plus 1, and right here you can easily find this 1/2. So when you want to find real number root quickly, don't forget about absolute value. All right, so don't forget about it. This is extremely important, because as you can see, without absolute value you can easily solve this question absolutely incorrect. But with absolute value, yes, you can see right here we solve this question completely in terms of real numbers. Yeah, in terms of complex numbers, only one way to solve it is to factor it to solve these quadratic equations, and as you can see we can easily do this. So if you want to cancel it, don't forget about absolute value. But if you want to solve this question completely and step by step, just try to factor it, which is extremely important thing in terms of in terms of math. So right now let's write our final answer. So x first, our answer, our all solutions, our answer. So x first equal to 1/2. We have x second and third equal to, we have 1/2 plus minus I square root of 3 over 2, so 2 pairs of complex roots. We also have x fourths and fifths, which is equal to 1/2 plus minus I over 2 square root of 3. Okay, this is our answer to our question, and we can easily like check the real quick this x equal to 1/2. I don't have enough space, so I hope I can easily check it right here. So when we check this x equal to 1/2, so I will check x equal to 1/2, because it's really complicated to solve. It's really hard to solve this to check our complex root, and we don't need it. But let's check our x equal to 1/2. Let's do this. So as a result, what do we have right here? 1/2 to the power 6, okay, equal to 1 minus 1/2 to the power 6. And I hope this is a correct expression, because we have 1/2 to the power 6 on our left side, and on our right side 1 is 1/2 equal to also 1/2, which is absolutely correct. So very tricky question. Don't forget about this absolute value. If you don't have, for example, enough time on your exam and you want to solve this question like with a real number, so you can easily write this with the absolute value. But if you want to solve this question completely, your teacher will be happy when you solve this question with this factoring method. It's not that hard, to be honest. We have a basic quadratic equation, a little bit simplification right here, and we have our final answer to this question. So thank you everyone for your time. Right now we can easily see a graph, you can easily see these points of intersection, you can easily see this interpretation in terms of like geometry, which is extremely important. Some students want to see this geometry interpretation, and I hope you enjoy it right now. So thank you everyone for your time. Wish you all the best in your mathematics adventures. Thank you everyone for your time. See you in the next videos.